While the whole world watches the US-China standoff over artificial intelligence, one Chinese company has been quietly and methodically building its own full vertical stack, from silicon all the way up to finished neural networks. That company is Alibaba. Over the past several months, it has revealed a series of moves that, taken together, look like a deliberate strategy. Its own AI accelerator chip, a language model with 2.4 trillion parameters, and tens of billions of dollars pouring into infrastructure. All of this is happening against the backdrop of US export controls, which have cut Chinese tech giants off from free access to Nvidia's top-tier chips. Today, we're breaking down exactly what Alibaba has shown, why it needs its own processors when it could simply buy ready-made hardware, and what all of this means for the global balance of power in artificial intelligence. There's a lot to cover, so settle in. This is going to be a detailed technical and strategic breakdown, with real numbers, dates, and specific products, not just headline claims from a press release. To understand Alibaba's logic, it helps to remember the context of the last couple of years. The United States has steadily tightened export restrictions on the most powerful AI accelerators heading into China. Those restrictions hit Nvidia chips specifically, the very GPUs and specialized accelerators that essentially the entire modern large language model industry runs on. For Chinese companies, that left one of two paths: chase workarounds and gray market imports, or build an independent ecosystem of their own. Alibaba chose the second path, and not just at the level of a single chip, but across the entire stack: hardware, interconnect, the software platform, and finally the neural networks themselves. This is the crucial point. Many companies stop at one layer, say they ship a chip and hope the rest of the market adapts around it. Alibaba, by contrast, is simultaneously developing its semiconductor business through its subsidiary T-Head, its cloud infrastructure through Alibaba Cloud, and its Quinn model family. That kind of vertical integration is an attempt to reduce dependence on any single outside supplier, whether that's a chip maker or a software vendor. And while moves like this used to look mostly symbolic, the 2026 releases show there's real, working technology behind them, technology that commercial customers are already using. The main character of this story is the Xen Wu M890 processor. It was unveiled in May 2026 at Alibaba Cloud's annual summit, developed by the company's chip division, T-Head. According to Alibaba, the new accelerator is roughly 3 times faster than its predecessor, the Xen Wu M890. That's a significant leap in performance, assuming of course you take the manufacturer's own claims at face value, since no independent benchmarks were presented at launch. On paper, the Xen Wu M890 is a specialized high-performance accelerator built for AI workloads. It ships with 144 gigabytes of built-in high-speed HBM memory, the same type of high-bandwidth memory that's critical for training and running inference on large models. Fast data exchange between chips is handled by an interconnect built on 8 independent ICN ports, with a combined bandwidth of 800 gigabytes per second. That lets multiple accelerators be linked into a single compute cluster without major losses in data transfer speed, which matters a lot when you're training models with trillions of parameters. The list of workloads the chip was designed for is fairly broad: classic training and inference of large language models, training autonomous driving systems, and multimodal training that combines text, images, and video. But Alibaba placed special emphasis on a different use case: AI agents. It's worth slowing down here, because this isn't just marketing language. By AI agents, Alibaba means software systems capable of independently chaining together actions and solving complex multi-step tasks with little to no human intervention. This isn't a single question and answer exchange like a typical chatbot. It's more like an entire workflow. The agent analyzes the task, calls on external tools, draws intermediate conclusions, adjusts its plan, and eventually delivers a finished result. That kind of work demands a fundamentally different hardware load profile. First, you need a large amount of memory to hold a long context, since the agent has to remember its entire history of actions and reasoning. Second, you need constant, fast data exchange between models, because agentic systems often run several neural networks at once: one for planning, another for generating code, a third for checking the result. Third, low latency under simultaneous requests from hundreds or even thousands of agents becomes critical once you're talking about industrial-scale deployment. Those exact requirements shaped the Xen Wu M890's architecture: large HBM memory, a fast interconnect, and a design built around running many processes in parallel. In terms of the price-to-performance ratio, Alibaba positions its chip as a realistic alternative to the Nvidia H200 specifically within the Chinese market, even though in raw compute power it likely still falls short of Nvidia's top-tier products like the H100. But when access to Nvidia hardware is restricted, the question isn't really who's faster in a vacuum. It's what's actually available to buy and deploy right now. It's also worth touching on market position. According to available data, the Xen Wu M890 holds the number 2 spot by market share among Chinese AI chip makers, trailing only Huawei's Ascend lineup, Alibaba's main rival in this race. The chip is reportedly already in use by more than 400 customers, according to some estimates. Named among them are China's state grid company, automaker Xpeng Motors, and telecom giant China Telecom. That's a meaningful signal. This isn't a lab prototype rolled out for a press event. It's a product being purchased by major organizations across genuinely different industries, from energy to automotive. The automotive use case in particular stands out, since training autonomous driving models is one of the most compute-intensive tasks out there. And Xpeng's willingness to trust this chip with that workload speaks to a certain level of technical maturity. Alibaba's ecosystem bet is built around the combination of processor plus cloud plus models. The company wants customers to be able to handle every AI need within a single platform, without ever stepping outside the Alibaba cloud infrastructure. Alibaba didn't stop at a single release. It went ahead and published a multi-year roadmap for its chip lineup. The next generation, called V900, is expected in the third quarter of 2027. According to the company, V900 should deliver roughly another 3-fold performance improvement over M890. If you extrapolate that claimed trajectory, a 3-fold jump from A10E to M890, then another 3-fold jump from M890 to V900. The cumulative performance gain across generations comes out to roughly an order of magnitude. Further out on the roadmap sits a chip called J900, slated for the third quarter of 2028. Publishing this level of detailed multi-year roadmap is itself a signal of confidence. Companies don't usually announce products 2 to 3 years out, unless they're fairly confident in the stability of their engineering program and their access to manufacturing capacity. For the industry, this means Alibaba treats chip development not as a one-off reaction to sanctions, but as an ongoing strategic pillar of the business, on par with cloud services and language models. There's also a manufacturing dimension worth noting. Designing a chip architecture in-house is only half the equation. Actually fabricating those chips still depends on a limited circle of foundries worldwide. So a public roadmap stretching into 2027 and 2028 also sends a message to supply chain partners that demand for these chips will be stable and growing, which is worth investing manufacturing capacity toward now. For outside observers, this kind of multi-year visibility is rare, and it stands in sharp contrast to how most announcements in this space usually look. A single product shown off with vague promises of future improvements. Alibaba, instead, names specific quarters and specific performance multipliers, which makes its position far more checkable. In 2 or 3 years, it'll be easy to compare the promises against reality. Hardware is only half the story. The other half is what actually runs on that hardware. And there's plenty happening there too. Back in the second half of last year, Alibaba already introduced its Qwen 3 Max model, which immediately moved the company's stock price and reinforced investor confidence in the potential of its AI business. In 2026, Alibaba went even further, unveiling a preview version of its flagship model, Qwen 3.8 Max Preview. Its claimed size is 2.4 trillion parameters, which is in the same order of magnitude as the very largest models that exist anywhere in the industry today. By Alibaba's own account, this model ranks among the strongest on the market, second only to Anthropic's Claude Fable 5. One caveat is worth flagging here. At the time of the announcement, no independent benchmarks or full technical documentation for the model had been published, so claims like this should still be treated as the company's own position pending outside verification. The model is already available to subscribers of the Alibaba token plan, as well as on the Coder and CoderWork platforms. Separately, the company announced its intention to eventually open source the model's weights, meaning make it available for local deployment and fine-tuning by outside developers, which, if it actually happens, would be a significant event for the entire open-source AI community. Interestingly, alongside the race for sheer parameter count, Alibaba is also pushing in exactly the opposite direction. Models that bet on efficiency rather than raw computational muscle. A good example is Qwen 3.5, a 397 billion parameter model built on a mixture of experts' architecture. The idea behind this approach is that despite the large total parameter count, only a small fraction of those parameters gets activated to process any given token, in this case, roughly 17 billion. That delivers flagship-level intelligence at a fraction of the compute cost. According to reported figures, decoding speed increased anywhere from 8.6x to nearly 19x compared to previous solutions, while operating costs dropped by around 60%. Thanks to FP8 support, memory requirements were also cut roughly in half. On top of that, the model was trained simultaneously on text, images, and video using a so-called early fusion approach, which lets it analyze videos up to 2 hours long and reliably operate graphical user interfaces, essentially controlling software the way a human would while looking at a screen. This push toward efficiency looks like a natural extension of the whole in-house chip story. If compute resources are constrained by sanctions, it makes sense not just to scale up hardware power, but also to shrink how much compute the models themselves demand. Behind this entire technology race sits some genuinely serious money. According to available reports, Alibaba has announced that it's raising its AI-related investment to $53 billion. That's an enormous sum even by the standards of the world's largest tech companies. And it makes clear that for Alibaba, artificial intelligence isn't a side project. It's the core bet for the years ahead. The logic here is straightforward, if ambitious. By combining large language model development with building its own chip ecosystem, the company is aiming to control the entire vertical AI stack, from silicon and data centers all the way to the cloud platform and the applications that reach end customers. In theory, that delivers several advantages at once. First, independence from outside suppliers under sanctions pressure. Second, the ability to optimize the entire chain, from chip to model, for specific workloads, rather than adapting to someone else's hardware and someone else's software interfaces. Third, potentially better economics, a company that simultaneously produces the chip, the cloud infrastructure, and the model itself can offer end customers more integrated and possibly cheaper solutions than competitors who have to buy components from third-party suppliers. Zooming out, the Alibaba story is part of a much bigger process. As the US continues restricting exports of advanced AI technology, China itself has started discussing mirror image measures, including the possibility of limiting foreign access to its own most advanced domestic models. If both technology superpowers, the US and China, keep moving toward restricting exports of their most powerful systems, the global AI industry risks splitting into separate technology blocks. In that scenario, the most powerful systems would stay locked within national ecosystems, and the free exchange of cutting-edge technology would become the exception rather than the norm. Alibaba's moves are worth reading exactly in that context. The company isn't just building a competitive product, it's constructing a full backup ecosystem for a future where access to Western technology could become even more restricted. Huawei is heading down a similar path, by the way, with its Atlas architecture built on Xen chips. And at the recent World AI Conference in Shanghai, several other Chinese companies, including Biren and Meta X, showed off their own alternatives to Western hardware, focusing not just on the chip itself but on software stacks too. Domestic equivalents of CUDA, designed to let workloads migrate from Western hardware onto homegrown silicon. It's important to understand that Alibaba isn't operating in a vacuum. It's part of an entire national push for artificial intelligence actively backed by the Chinese state. A telling example is the humanoid robotics market, which relies directly on the same AI agent technology the Xen Wu M890 chip was designed around. According to officials from China's Ministry of Industry and Information Technology, humanoid robot production in China could exceed 100,000 units in 2026. That statement came at a press conference ahead of the very same World AI Conference in Shanghai, where Alibaba, Huawei, and a whole range of other Chinese chip makers showed off their hardware. Officials also noted that AI application adoption at large Chinese industrial enterprises has already surpassed 30%, meaning demand for inference and training compute is only going to keep growing, and not just from tech companies, but from traditional industry as well. In that light, Alibaba's bet on chips purpose-built for agentic workloads, with long context windows and support for running many processes in parallel, looks like it's landing squarely at the center of real demand, not just clever marketing positioning. State backing shows up in another way too. Alongside the growth of domestic capabilities, Chinese regulators are discussing tighter controls on exporting the country's most advanced homegrown models, essentially applying to themselves the same logic the US has applied to China for years. Now, the result is a kind of mirror image process, where both sides are simultaneously scaling up internal capacity and restricting how much of it leaks out. For all the impressive scale of these announcements, it's worth keeping a level head. Nearly every headline number here, the threefold performance gain of M890 over 810E, the number 2 ranking among Chinese AI chips, the claim of being the second strongest model in the world behind Claude Fable 5, comes from Alibaba itself, and none of it has yet been confirmed by independent testing or publicly available outside benchmarks. That doesn't necessarily mean the numbers are inflated, but it does mean they should be treated as manufacturer claims rather than verified fact for now. The history of the tech industry is full of cases where impressive launch day numbers turned out to be far more modest under real-world workloads. A second open question is manufacturing capacity. Designing a chip architecture is one thing, ensuring mass production is another, especially when access to the most advanced lithography equipment is itself partly restricted by sanctions. How reliably Alibaba can scale up production of the M890, and later the V900, remains to be seen. A third issue is the software ecosystem. Even the most powerful chip is useless without mature software, libraries, and developer tools. And today, most engineers worldwide are used to working within Nvidia's CUDA ecosystem. Moving to Chinese alternatives takes more than willingness. It takes time, and developers willing to retrain. So the real test of Alibaba's entire strategy still lies ahead. And the next year or two, right up through the V900 launch in 2027, will be especially telling. So here's where things stand. Alibaba has shipped its own AI accelerator, the Xen Wu M890, which is 3 times faster than the previous generation, packs 144 gigabytes of HBM memory, and is already in use by hundreds of commercial customers across different industries. The company has published a multi-year roadmap featuring the V900 and J900 chips. In parallel, its Qwen model family keeps expanding, from the massive 2.4 trillion parameter Qwen 3.8 Max preview to the efficiency-focused Qwen 3.5, which bets on lower compute cost rather than sheer size. All of this is backed by $53 billion in investment and a strategy of full vertical control over artificial intelligence, from silicon to finished application. Whether Alibaba will actually manage to compete with Nvidia and leading Western labs on performance is still an open question, and many of the company's claims currently rest only on its own data without independent verification. But strategically, these moves look genuinely well thought out. This isn't a single flashy release. It's the deliberate construction of an independent technology ecosystem built to last for years. Do you think this model, your own chips, plus your own models, plus your own cloud, becomes the new normal not just for China, but for other regions too? Let us know what you think in the comments. And if you found this breakdown useful, hit like and subscribe. There's a lot more coming on how the global AI industry is being reshaped.